Hey guys, I'm Rishabh. Today we are going to talk about kinematics topic, acceleration. Last time we have discussed on the topic of instantaneous velocity. So, acceleration. What is acceleration? Acceleration is change in velocity per unit time. So, if a particle changes its velocity per unit time, we can say Vt, where V changes as t changes. So this is a particularly acceleration, and if we want to define it, A is equal to V minus V naught upon t, and if we want to assume it in a graph, then we can say this is A and T, where this is a AT graph, and if we want to understand acceleration, then this we can say change in velocity per unit time. So change in velocity per unit time. So this is we can let us point out some notations like V, and this is V naught, or we can say V naught or V. So V minus V naught upon t is equal to acceleration. So next we are going to discuss on average acceleration. So average acceleration is also change in velocity per unit time, but here the change in time is a time interval. If we take V minus V naught upon टाइम, यहाँ पे आपका टाइम नहीं होगा, यहाँ पे आपका होगा t minus t naught, and we can say del V upon del t. So where particle has velocity, where in this average acceleration, we can say that particle have velocity v1 v naught at time t naught, and also v at time t. So if we want to find out instantaneous velocity, then we have to shrink out the time interval tends to 0, which is closer to 0 but not 0, and here we are going to use limiting value of del t. So A is equal to basically limit del t tends to 0, del V upon del t, which we can write as t dv upon dt. In words, we can say the acceleration of a particle at any instant is the rate at which its velocity changing at that instant, and also at that instant, and also we could write acceleration at that instance means at that particular time instant, which is very small quantity, So in other words, we can also write it as A equals dv upon dt equals d upon dt dx upon dt is equal to d square x upon dt square. So this is the another way we can write the instantaneous velocity. In words, the acceleration of a particle at any instant, it means at any time instant, is the second derivative d square x upon dt square of its position xt. xt means change in t is a function of x. T is changing per unit, x is changing with respect to time. So this is the instantaneous velocity, instantaneous acceleration. Moving on, let's talk about constant acceleration, which is very important topic, constant acceleration. When the acceleration is constant, the average acceleration and the instantaneous acceleration are equal. When acceleration is constant, acceleration is constant, tends to constant, then we can say that average acceleration equal to instantaneous acceleration. So we can write it as A equals A, this is instantaneous, average equals V minus V naught upon T minus T naught is equal to 0. Let's write it first. Then A will become V minus V naught upon T minus 0, which is also equal to V minus V naught upon T. So let's take it as equation 1. Moving on, here here we can say v naught is at t is equal to 0 and जो v है वो है at t is equal to t. So if we can use notations, it means if we change notation, then we already have changes the notation because v naught is v1 and v is v2. You can understand it. I'm just let's clarify it. V times to v2 and v naught times to v1 equal to. So we can also write the equation. We can also write the equation 1 as which is a equal to v minus v naught upon t. Then we can also write it as at equals v minus v naught, and also we can say v equal to v naught plus at. This is equation second. Moving on, and if we derivate the second equation, if we differentiate the second equation, then we can get dv upon dt equal to a, which is the definition of acceleration. If there is a constant time, then we could also change the average velocity formula. If there is a constant in time, then we can also change the average velocity formula. So what is the average velocity formula? Last time we have talked about the average velocity formula is x2 minus x1 upon t2 minus t1, or we can say it as x minus x naught upon t minus t naught, where t naught is equal to 0, and it becomes x minus x naught upon t. So we can also write it that v average is equal to x minus x naught upon t. This is the equation number 3. So if we want to rearrange it, then it will become v average into t equal to x minus x naught, and we can also say that x is equal to v average t plus this plus sign, this is t x naught, which is also a fourth equation. Just rearranging it, that t multiplied with v average, and x naught goes to minus 2 plus on the other side, on the left hand side. So now if we are considering the average velocity as if we are considering average velocity, now let us talk about normal average. If there is two component a and b, then average will be a plus b upon 2. So at any time instant, let t is constant, then we can say that v average is equal to v plus v naught upon 2, or v naught plus v upon 2. So moving on from this formula, we can also write it as v average is equal to 1 by 2 v naught plus v. Let us this is also an important equation. Let it put as equation number 5. So let us put something like here equation 2 in equation 5. Then what do we get? What is equation 2? V is equal to v naught plus 80, and here we have v average equal to 1 by 2 v naught upon half into v naught plus v, which is initial and final velocity. So if we are going to put equation 2, putting equation 2 and equation 5, that implies v average becomes 1 by 2 v naught plus v naught plus 80. This is v naught plus 80, and this is v naught plus 80. That implies that will become v average equal to 1 by 2. ये जो v naught है ऐड हो जाएगा 2 v naught plus 80. So it will become v average equal to v naught plus 1 by 2 80. This is also an important equation. Let's write it as equation 6. Now moving on, substituting the equation 3 means equation 3. Where is equation 3? V average equal to x minus x naught upon t. In the V average in equation 6. Putting equation 3 in equation 6. Then what we get? What is the equation? X minus x naught upon t. So x minus x naught upon t equal to v naught plus half at, and t will multiply there in our in right hand side, then it will become v naught t plus half at square. This is also an important equation. So the equation 7 and equation 2nd is the basic equation 7th. And equation 2nd is the basic equation of constant acceleration. Moving on. So there will be a new formula generated if we अगर हम स्क्वायर कर दें, if we square equation 2nd, then what will we get? What is the equation 2nd? V equals v naught plus at. Then we will find it will become v is equal to v naught plus at, and after squaring it will become v square v naught plus at square. Then v square is equal to v naught square plus 2 v naught at plus at a square t square, and v square is equal to v naught. If we take 2a common here, what do we get? V naught t plus half at square. First there should be half multiplier to common out 2. So what is this formula? What is this equal to? This equal to, from equation 7 we can write it as x minus x naught. So it will become v square equals v naught plus 2a x minus x naught. This is also an important equation. Moving on, if we want to find equation without acceleration, how we can find without acceleration? Equation without acceleration. Then we just need to substitute equation 2nd into equation 7. That is equation 2nd, v is equal to v naught plus at into equation 7. X minus x naught is equal to v naught plus half at square. So let's arrange equation 2nd as a is equal to v minus v naught upon t and put it in equation 7. Then what will it become? It will become x minus x naught equals v naught t plus half v minus v naught upon t into t square. Then 1t is cancelled out here. Let's cancel. And it will become x minus x naught equal to v naught t plus half v t minus half v naught t. So this is 1, this is half. 1 minus half is equal to half. Then we can say half vt minus half v naught t, sorry, plus half, plus 1 minus half is equal to plus half. That implies it will become half v plus v naught into t. That implies x minus x naught is equal to half v plus v naught into t. So from this equation we can also eliminate v naught through equation 2. If we put equation 2 here, this is also an important equation. Let's put it as equation 9. If we put equation 2nd in equation 9, we get x minus x naught equals if we rearrange the second equation as v minus v equal to v naught plus at as v naught equal to v minus at. So we are going to put that the value of v naught in here. Then what we get? Half is equal to v plus v minus at into t. So what we get? X minus x naught equal to half. This is 2vt, which cancel out 2v minus a t into t. Then it will become x minus x naught. X minus x naught equal to v minus half at square, which is also an important equation. Let's put it as equation 10. So moving on, the summary is we have all the equations: equation 10, equation 9, 8, 7, 6 and 5, and also second equation. We can see there is always some equations, some values are missing out. Let's find out what are the values which are missing out. Equation and missing missing value. So from the second equation, v is equal to v naught plus 80. The missing value was x minus x naught. The second, x minus x naught is equal to v naught plus half 80. The missing value is v. V square is equal to v naught square plus 2a x minus x naught. The missing value was t, and x minus x naught is equal to half v naught plus v into t. The missing value was acceleration, and x minus x naught is equal to vt minus half at. The missing value was v naught. So that's all for today. In the next session, we will discuss. We will do some questions using these formulas. Thank you.